Hi, my name's Laura Martin, and I'm the Odin Train business owner, and I'm here to talk about what Team Artemis has been doing in PI 27. This was an exciting PI for us because we started delivering data, which means we're actively providing critical business value to our customers. Our business owners and team are going to highlight some of that work that we've been doing this PI. The first release was a national data set on conservation practice geometries for the Inflation Reduction Act greenhouse gas quantification effort. The conservation practice data team centered at the Economic Research Service needed a national geospatial data set for their modeling work. The data is privacy protected NRCS data on conservation practices that were certified by our field staff as part of program delivery work with customers. The ground truthing and digitized practice geometries can be used by the conservation practice data team to validate other remotely sensed data layers. We were able to process a national layer with 10 years of practice data in a few short minutes for their analysis, which we delivered with a Geospatial Data Act compliant metadata record. And I'm going to turn it over to Jerry to show some of that work on this data set.
And as we can see here, one of the challenges is we had to dig into what was the use case for this data. In this case, they wanted to use the geometric acreage to act as input and ground truthing for their greenhouse gas machine learning. But some of the geometries are a lot bigger or a lot smaller than the certified acreage. So we had to go through and remove the either geometries that were either too big or too small so that those geometries weren't skewing the results of their machine learning results. So with that, we'll turn it over to Travis.
All right, thanks, Jerry. So one of the other priorities for conservation geo development has been to replace the IDEA geospatial extract, which basically is the geospatial extract of some of the INPAD conservation planning information. And so the IDEA pipeline has been broken for several years, and it's really caused some major issues with states wanting to be able to utilize this data to conduct analysis. And so states typically use this type of information for things like the state resource assessment and prioritizing areas within the state that may be lacking conservation work, but a myriad of different types of analysis can be done using this data. And so we wanted to be able to replace that as part of it, as part of the conservation geo implementation. So really what you could say is this current extract would be called the IDEA Extract Plus, because it really has additional information contained in the extract to include things like draft and alternative and cancel practices, which in the past we only had planned and applied. The land unit feature class now has additional information to include things like tract number, land unit number, it also, I guess, contains the status of the land units. All of these things can be done to improve the ability to do analysis with this geospatial data that we're extracting today. So there's a number of improvements. So I would really call this IDEA Extract Plus, because there is definitely additional information and better ways to utilize this information. One of the things that was helpful is we were able to utilize GIS States Portal as a clearinghouse for the extracts. And so this really helped fast track the ability to get this data out the door. So otherwise we'd have ended up building our own data store and having to get that through an ATO. And so in this case, we're able to utilize an existing system to provide this information. So with that, I'm going to turn it back over to Jerry.
So here we see an FME model that we developed to read data out of our Postgres databases. And the first thing we're doing on a weekly basis is to take a file geodatabase template and duplicate it for each state and territory that we're generating. And then this portion, we generate the planned land unit feature classes in each of those state file geodatabases, and then the practice points in each. Then we load it up into the Geo Portal platform, all going from our Postgres database into the Geo Portal as zip file geodatabases with the single model. So let's go take a look at the Geo Portal. So here in Geo Portal, we have one Geo Portal site per state. And this allows us to control access on a state-by-state basis. Like Travis was saying, we were able to take advantage of this secure boundary to deploy our data quickly and control access on a state-by-state basis. If we come in here and look at Maine, we're creating 2 objects per state. One is the actual file geodatabase that each state can download, getting updated on a weekly basis. The other is the metadata record that we share so that each state, has an official metadata record related to it. If we go look at the metadata record here, it includes all 100 fields and a lot of details related to it. And so, yeah, since we talked about metadata, let's turn it over to Kennedy to continue on with the metadata discussion.
Thanks, Jerry. Yeah, so we can all agree that metadata is crucial to understanding and also managing our data. To make the process more efficient and reusable, the team identified a need to streamline this process by building and storing structured metadata asset inside our database. The idea is a quick retrieval when it's needed. Basically pay the debt now and then enjoy the future use of it. To make this happen, we captured all pertinent information on columns using our various data products from both database perspective and then also from a business user perspective. To achieve this, we focus on gathering information from disparate sources, working with various teams, combining and structuring metadata, key highlights, key aspects such as the column definition. We talk about the data types, the expected domain values, ranges of these numeric values and all that. And then by organizing this information, it's already stored inside our database, and we can retrieve it when we actually need it for documentation.
So let's turn it over to Adolfo.
Thanks, Jerry. Hello, everyone. My name is Adolfo Diaz, and I will be taking over as the government product owner for Team Artemis in PI 28. Now that Team Artemis has started delivering valuable products to customers using different delivery methods, as we previously heard from the team, we need to automate and scale up. Take that a little bit further. The future focus for Conservation Geo will be on workflow automation of these products and other prototypes using metadata-driven schemas to efficiently deliver better information to more customers and standardize the quality control process while updating their metadata dynamically. I look forward to collaborative ideas that will continue to enhance our current products and develop new products in PI 28. Thank you and great job, team.